Alright, in this lesson we're going to be working with or learning about polynomial functions. First we're going to review over polynomials, what those are. You've worked with them a lot this year and in algebra also. Then we'll get into the polynomial functions, what the graph would look like, and then given a certain value for x and substitute it into the equation, what that answer would be or what that would look like. Alright, quick review over polynomials. So the polynomials, there can only be one variable in the expression. So it could be x, y, whatever, it doesn't matter, but only one variable in it. No negative exponents and no variables can be in the denominator at all. So the first type of polynomial would be a constant. So let's just say we had 4. And you're thinking probably, well, where's the variables? Because there's only be one variable in the expression. Well, that could be written as 4 to the x to the 0 power. Because anything to the 0 power is 1, so that's really 4 times 1, which means that equals 4. So that's the first type of polynomial. The second one would be like linear x plus 5. And we'll look at all these as soon as I'm done with these, what the graphs would look like if we would graph those. Quadratic, those are going to be like x squared plus 5x plus 6, or they're going to be in the form there. So the highest number on the exponent would be a 2. Cubic is going to be in this form. So negative 2x cubed minus 5x squared plus x minus 3. So cubic, the exponent, the highest exponent is going to be 3. And quartic, that's going to be to the fourth power, so we could have like 3x to the fourth power minus 2x plus, 5. And our last one, it could be negative 1/2 x to the fifth plus x to the fourth minus 2x squared plus x, and that could be it there. So you can see the highest exponent there is going to be a 5, so that would be quintic. So we have constant, linear, quadratic, cubic, quartic, and quintic. And I'll show you on the next slide what all those look like if we were to graph them. Alright, so the difference between a polynomials and polynomial functions is that the polynomial functions just have an f of x in front of it. So we'd have like f of x equals 4, f of x equals x plus 5, f of x equals x squared plus 5x plus 6, and so on. And I'm going to show what the graph looks like of those. So the graph of f of x of 4 would just be like a straight line. It's linear, going through 4, or it could be negative 4, negative 5, wherever. It's just going to go through the y-axis at that point. The linear, that's for the constant, I'm sorry. For the linear, that's going to look like something like this. So this one would be, let's say, starts at 5, and it's going to go up this way. Or it could go have a negative slope, but it can never, ever go through the x-axis. And same way with a constant, you cannot have a line going through the x-axis. That is not a function. It only can go straight across through the y-axis. For the quadratic, it would be, and we've looked at quite a bit of those, so that's going to be something in a U shape. So it could be something like that, or it could go down. So it's going to be U-shaped there. For a cubic, and you can go back to the previous page to see what the polynomial looked like that, because it's the same polynomial, but it just have an f of x in front of it. It still has a exponent of 3, that's the highest exponent, that's the degree of the polynomial. And that graph would look like, kind of like this, something like that. So one of the arrows is going to go up and one's going to go down. On the quadratic, both arrows go up or both arrows go down. And for the quadratic, or excuse me, the quartic, I'll do that one over here. That's going to look something like this. And then for the quintic, and you probably can guess, that's going to cross the axis 1, 2, 3, 4, 5. So the degree of the polynomial, which means the largest exponent in your equation, tells you how many times it's going to cross the x-axis. So the linear crosses once. The quadratic either crosses twice or none. If it doesn't cross at all, then it's going to be imaginary numbers. The cubic crosses the x-axis 3 times. Quartic crosses the x-axis 4 times. And the quintic crosses the x-axis 5 times. And also, every time it crosses the x-axis, those are considered zeros, which means if I would take that point, the x value of that point, and put it into my equation, my answer would come out to be 0, which makes sense because if I'm on the x-axis, my y value is already 0. So the points that are right on the x-axis, every time that graph crosses the x-axis, those are called zeros, meaning if I would take the x-coordinate of that point, put it into my equation, my answer would come out to be 0. And let's go back to one page to look at the coefficients on there. So just like with polynomials and polynomial functions, especially in functions, the number that is in front of the exponent that has, the variable that has the largest exponent is called the leading coefficient. So on this one, it would be a 1. The leading coefficient on this equation in the cubic would be -2 because the highest exponent is the 3. In the quartic, the leading coefficient would be 3 because the highest exponent in this equation is a 4. And the quintic, the leading coefficient would be -1/2 because the highest degree of this polynomial is 5. So the largest exponent on that one is 5. So the leading coefficient is the number that's in front of the largest variable that has, the variable that has the largest exponent, which is called the degree of the polynomial. Alright, so now we're going to evaluate some polynomial functions. So we have the function 6x plus 10. We want to evaluate that when x is -3. So wherever I see an x in the equation, I'm going to put a -3. So I'm going to have 6 times, then put my -3 in for x, and then plus 10. So I'd have -18 plus 10, that's going to give me -8. So my answer to that would then, when f of -3 is going to be -8. So whenever f of -3 is put in the equation 6x plus 10, my answer is going to be -8. So that's how the answer would be written. So let's try another one there. Here we have function x cubed minus x squared minus x plus 4. So this is cubic because the degree on this polynomial is 3. That's the largest exponent on the variable. And wherever we see a -3, or wherever we see an x, we're going to put a -3 in our equation. So I'd have -3 cubed minus -3, let's make that into red so you see that, squared minus -3, and then plus 4. So that's what we did there. I put -3 in for x, so -3 cubed is -27, minus -3 squared, which would be -3 squared is 9, so minus 9, minus -3 plus 4. So this is going to be -36 plus 3 plus 4. -36 plus 3 is -33 plus 4, and -33 plus 4 is -29. So at f of -3, the answer is going to be 29. So that's how that answer would be written. So whenever we put -3 into our function above, that's the answer we would get. So now we have p of x squared minus 4x minus 9, so this is quadratic. Wherever we see an x in our function, we're going to put an x minus 1. So right there we have x squared, so that means we're going to put then x minus 1 squared, because I have an x there. I know it's kind of confusing because I have x in both of them. But wherever I saw an x in my original equation, I put an x minus 1 minus 4 times x minus 1, and then minus 9. So x minus 1 squared means x minus 1 times x minus 1. So I had FOIL that, so I had x squared minus 2x plus 1. And over here then I would have, distribute that, negative 4x plus 4. Oops, forgot the x. So add that 2 there, minus 4x plus 4. And then I have my minus 9. I've got to put that in there. So now I add all my like terms together. So I have an x squared. I can put the negative 2x and the negative 4x together, which would give me negative 6x. And I can put the 1 and the minus 9, which would give me then minus 8 then. So at p, at x minus 1, my answer is x squared minus 6x minus 8. So that would be my answer there. Oops, and I made a mistake there. I forgot to put this 4 there. So really this should be a 4. This should be a 4 then. Sorry about that. Hopefully you caught my mistake there. But that would be your final answer. So on this one we have p times is x cubed minus 2x plus 1, so it's cubic. And I have the evaluate at a plus 2. So wherever I see an x, I'm going to put an a plus 2, so I've already done that. And now I'm going to evaluate this. So a plus 2 cubed means a plus 2 times a plus 2 times a plus 2. So I'm going to FOIL the first two. And once I FOIL the first two, I would get then a squared plus 4a plus 4. Then I would take that and multiply that by a plus 2. Which would be this last one here. That's where I'm getting that. And once I distribute that to all the terms, just draw arrows to save some time there. So I'm distributing that to every single term in there. Add an a cubed plus 4a squared plus 4a plus 2a. Then I would distribute this here to here to be minus 2a minus 4. And then plus 1. Let me erase that, because that's not quite right there. So, you have 2a squared plus 8a plus 8. Then, when I would distribute this way up here, then I'd have a cubed plus 4a squared. Let's see, or excuse me, that'd be 6. Boy, I'm making a lot of mistakes here, aren't I? At least I'm catching them. 6a squared plus 12a plus 8 minus 2a minus 4 plus 1. So my answer would be a cubed plus 6a squared plus 10a plus 5. Alright, the next one is 2x squared minus 4x plus 6. And I'm going to evaluate with two of them, g at 2 and minus g at negative 3. So I first did g at 2, put that into my equation, and I got 6 as my answer. You can see my work there. Then I evaluated with g at negative 3 and got my answer at negative 6. And then for my equation up here, I need to subtract the 2. So then I have 6 minus 36, which would then give me negative 30. So that would be my final answer there. Alright, the next one would be the function x plus 5. Then it says take 5 times whatever f of 3 is. Well, first I put f of 3, so I put 3 in for x. So 3 plus 5 is 8. Then once I get that answer, then I take 5 times that answer. So I took 5 times the 8 and then got 40. Alright, my last one is function 5x squared minus 3 and evaluated when the function of x is x plus h. So wherever I saw an x in my function, I put an x plus h. So it's 5 times x plus h squared minus 3. So that means x plus h times x plus h. Foiled that, and that's what I got when I foiled this right here in the green. And once I foiled that and combined the like terms, that's my answer there. Then I would take 5 times each one of those, because it's 5 times that part, and then I'd get my final answer there.